This tape is on Chapter E. Operations on multinomials. Adding and subtracting multinomials is similar to adding and subtracting monomials. Multiplication by a monomial. Multiplication of a multinomial by a monomial is constructed as follows. Let's take 4x cubed y z squared multiplied by 6x plus 3y squared minus 5xy plus 2. There is no restriction regarding the number of terms in the expression within this set of brackets. Here the product is obtained as follows. The factor 4x cubed y z squared is multiplied by each of the terms within the brackets separately, one at a time. In other words, if you take 4x cubed yz squared times 6x, we have, taking care of the numerical part first, 6 fours are 24. Multiply this expression by x, thinking of the laws of exponents if you like, increases this to x to the fourth, y z squared is the rest of that part of the answer. Multiplying this now by plus 3y squared, taking care of the numerical part first, that's 12, followed by, well, y and y squared will change that factor. By the laws of exponents, we have y cubed and z squared. No changes in those powers. Multiply again by minus 5xy, taking care of the numerical part first, that's negative 20. The x and multiplied by x cubed here will be x to the fourth. Y will increase by a power factor of to 2. And finally z squared, no change. The final term becomes 2 multiplied by all of that, and that's simply 8x cubed y and z squared. On the other hand, multiplication may be restricted to polynomials only, such as in 3x, this is our first example as a multinomial multiplied by a monomial. Here we are going to have a restricted example dealing with polynomials, and the example I want to work on is 3x multiplied by 4x squared minus 2x plus 7. 3x is multiplied by each of the terms within the brackets. 3x times 4x squared is equal to 12x cubed. 3x times this amount is minus 6x squared, and 3x by 7 is plus 21x. Here's another example. 4 minus 2x multiplied by 7 minus 8x. This amounts to, well, 4 is by itself there, and we repeat it. Negative 2x is multiplied by 7, and we have negative 14x. 2x is multiplied by, actually minus 2x multiplied by minus 8x, and that is positive 16x squared. We will now do examples dealing with multiplication by a binomial and more. Multiplication by multinomials contains two or more terms will be illustrated, but the emphasis will be on polynomials of 1 and 2 variables. For example, ax minus y squared multiplied by 3x z to the fourth plus x cubed y minus 2x squared. Here we have two multinomials being multiplied out. Sorry, this should have been x to the fifth. The interpretation of this example is that this amount in brackets containing two terms is multiplied by this amount in brackets consisting of three terms. In a short step in the solution, we would take the first term here of this expression, pick it out, and multiply it by all of the in the next set of brackets. And so this is its interpretation. Followed by minus the next term of the first multinomial, which consists of y squared, and it is multiplied by the contents of, so I'm writing all of the parts of the solution in this example. I will have to continue on a new line. And so that's what it means. This results as 3ax squared z to the fourth. Continuing, we have ax to the fourth y minus 2ax to the sixth. Of minus 3x y squared z to the fourth. And continuing down here, because I have run out of room, we have minus y squared times this amount is negative x cubed y cubed. Negative y squared times negative 2 makes it positive 2 x to the fifth y. There is more interest in binomial multiplication of polynomials, say for one variable. For example, 4 minus 2x multiplied by 7 minus 8x. Interpret the multiplication of this binomial by the second one as being equivalent to the first term 4 multiplied by 7 minus 8x followed by minus 2x multiplied by 7 minus 8x again. Simplifying, we have 28 minus 32x. We have minus 14x plus 16x squared. Adding like terms, 32x with the 14x, we write the final answer as 28 minus 46x plus 16x squared. The kind of multiplication which I illustrated in the example just done is often referred to as horizontal multiplication. Now I will show you another common way of multiplying binomials referred to as vertical multiplication. The same example, 4 minus 2x multiplied by 7 minus 8x, but notice I have written 7 minus 8x underneath. Now be very careful in following the procedure in multiplying these pairs of terms. I'm going to put on the side here the way we would normally write out a problem using ordinary numbers. If I had, for example, 42 multiplied by 78, the procedure for multiplying that in ordinary arithmetic is to multiply 8 by 2, then followed by 4 by 8, and you would write one line of numbers. In this particular case, it is 16. 4 8s are 32, and 1 is 33. Having done that, you would then begin with 7 and go through the same process. You'd take 7, multiply it by 2, and then you would take 7 and multiply it by 4, and you'd put it in this line. Well, showing the result of this product, you have 7 times 2 is 14, 4 7s are 28, and 1 is 29. These are sometimes referred to as partial products. The three, of course, the total product would be the sum of these two rows of numbers, right? So that's how we would normally multiply when dealing with ordinary numbers. Procedure is quite similar with algebraic expressions, but there are some differences. We begin to multiply from the left to the right instead of, as we did here, from right to left. Observe, we take 7 times 4 first, followed by 7 times minus 2, and that is minus 14x. That's a partial product of the total that we're after. And the next step is, of course, to multiply by minus 8x. Each of 4 and minus 2x are then multiplied out in the algebraic problem. Minus 8x times 4 minus 32x, and notice it goes over here. The partial product seems to flow this way in algebra, but in ordinary arithmetic it flows this way. Then multiply minus 8x by minus 2x, and the answer is plus 16x squared. There are your partial products, and the sum will be the total product. It is 28 minus 46x plus 16x squared, and it's the same answer that we had earlier. Here is another example of multiplication using polynomials. We'll take a, multiply it by a minus 3, followed by a squared plus a minus 1. We can solve this problem by applying horizontal multiplication. We're going to have to break away and do some work on the side. We want to multiply those two amounts first. That's usually the best procedure, and save the single term a to multiply later. It's much easier that way. We can then say that this is equivalent to a followed by a squared plus a minus 1 minus 3 followed by a squared plus a minus 1. Horizontal multiplication. This is a cubed plus a squared minus a. This amount is minus 3a squared minus 3a plus 3. Simplifying like terms, a cubed, this together with that adds up and gives minus 2a squared. These two add up to give minus 4a and plus 3 finally. Now, coming back to the main problem, we can see that we still have to multiply a by that amount. And the final answer then is a to the fourth minus 2a cubed minus 4a squared plus 3a. I would like to show you the part within this brace section of the problem as vertical multiplication. We write a squared plus a minus 1 multiplied by a minus 3. Notice how I've made sure the binomial here at the bottom is written to the left in this fashion. Continuing then and obtaining partial products, we have a cubed multiplying those two, followed by multiplying those two, followed by multiplying the third one, which is minus a. Repeat with negative 3, and we have negative 3, negative 3a squared, followed by negative 3a, followed by positive 3. Those being the partial products are now added, and we end up with a cubed minus 2a squared minus 4a plus 3, the same result as we had before. Of course, now we continue by multiplying by a, and we'll get a to the fourth minus 2a cubed minus 4a squared plus 3a. The examples I've just shown you deal with polynomials in one variable. Now I will do some examples where polynomials are of two variables. For example, 2x minus 5y multiplied by x minus 2y quantity squared. We will have to handle this problem by doing some work on the side. We have a binomial to multiply by this binomial and once more again. Let's do the satisfy the power portion first. That means that x minus 2y is multiplied by x minus 2y. That's what the square means. It's a power. This amounts to x squared minus 2xy followed by minus 2xy and finally plus 4y squared. The sum is x squared minus 4xy plus 4y squared. This amount replaces this amount because they are equal. The problem continues then to be the same as 2x minus 5y multiplied by x squared minus 4xy plus 4y squared. I would continue with the solution, having written the first part down here to the right, by multiplying 2x minus 5y vertically here. 2x multiplied by each of the terms above, I have 2x cubed minus 8x squared y plus 8xy squared. Follow this by multiplying each of the three terms by minus 5y. It's minus 5x squared y. That'll go under this, since they're like terms. Minus 5y times that is plus 20 xy squared, and finally minus 20 y cubed. Those partial products are now added, and we have 2x cubed minus 13x squared y plus 28xy squared minus 20y cubed. All these terms fall neatly into place. And so that is the final answer. Next is division by a monomial. For example, 3x to the third y to the fourth plus 18xy to the fifth z squared minus 27x to the fourth yz to the fourth, all divided by 3x cubed y squared and z cubed. Let me introduce some terminology. The top part of the fraction which can be called the numerator, and the bottom part of the fraction, which can be called the denominator, can also be referred to as the dividend for that one and divisor for this one, when dealing with the idea of division. The procedure is to separate each of these terms on top, and there are 3 of them, into single fractions with this divisor. So note very carefully that we have 3x cubed y to the 4th over 3x cubed y squared z cubed. 18x y to the 5th z squared divided by 3x cubed y squared z cubed, and finally minus 27x to the 4th y z to the 4th divided by 3x cubed y squared z to the 3rd. See how each term in the numerator, or the dividend, has been separated into individual problems where the divisor is written underneath each of them. The procedure is then simply to apply the laws of exponents to simplify each of these parts. So looking at this expression, we see that this is the same as that, this is the same as that. Y to the 4th divided by y squared leaves y squared on top and z cubed on the bottom. Plus, we have 3 into 18 is 6. The x and x cubed simplify to give x squared below, y to the 3rd above, and finally z below. In the last one, we have 3 into 27 is 9. We have x left because we have x to the 4th divided by x cubed, leaving x. The y portion, or y powers, simplify to give y on the bottom, and finally z on top. That's the final answer, and that's how we would divide by a monomial. Must remember the procedure. This answer can be referred to as the quotient. Dividend divided by a divisor equals a quotient. Next is division by a binomial. Division by a binomial will be illustrated with expressions which are polynomials. In simple terms, a polynomial in one variable is an expression containing powers with a single variable base. For example, 3x to the 5th plus 2x to the 4th minus 5x cubed minus 2x squared plus 6x minus 8. Only one variable occurs in the entire expression. Recall that the degree or size of the polynomial is the exponent value of the largest power. The largest power of the variable base x is this one. So the degree of this 5. Here is another example that is not a polynomial. For example, 6x cubed y minus 2xy to the 4th z squared plus 3x cubed yz is the example I want to illustrate with. Notice that division by a binomial will now continue. For example, take x squared plus 7x plus 12 and divide by x plus 3. There are two ways I can show this problem. This is one of the ways. This is the dividend, and this is the divisor. I can also express this problem in the way you have seen it shown before. X squared plus 7x plus 12 divided by x plus 3. Plus 3 divided into x squared plus 7x plus 12.